Okay guys, so in my last video, I went over the 4 steps we do when using application questions. I'm not going to review those in this video, so if you want to start with the easier one, go watch my previous video. So we'll just directly get started with the question. So here, the question is asking, a rectangle has a perimeter of 100 centimeters. What length and width should it have so that its area is a maximum? So from last time, remember that we need to come up with 2 equations and one that we can substitute in it. So first, let's start with our first equation. A rectangle has a perimeter of 100 centimeters. So it's saying that the perimeter of this rectangle is 100 centimeters. What we don't know is the length and the width. So we can assume those as x and y. You can use any variable, but I'm just going to use x and y. And to find the perimeter, it is 2 width plus 2L, because the perimeter is basically adding each side up together. So 2x plus 2y equals 100 centimeters. That will be our first equation. And our second equation will be what length and width should it have so that its area is a maximum. Now we're talking about area. So the length and width need to be such that the area is a maximum. And we can just directly use the area formula. Length times width equals A. You don't know the value of A, so you'll just put x times y equals A. Remember to use the same variables you used for your first equation. So I'll write them out. Okay guys, so here I wrote down both equations. And the next step is to rearrange one of these equations so that we can plug it into the other one. So the only logical one that we can start rearranging is this one. And you can rearrange for any variable, but I'll just go for x. So what you're going to do is first move y to the other side. So 2x equals 100 minus 2y. Okay? Now that you have 2x on its own, you need to find for just x. So you can directly divide the 2 on the other side. So x equals 100 minus 2y divided by 2 as a whole. Okay, that will be your rearranged equation. I'll write it out so it's easy to understand. Okay, guys, here I rearranged it, and just like I mentioned before, you will do 100 minus 2y all divided by 2. So now that you have a denominator, look for a way to simplify this. You can divide both terms by 2, so you can just directly do that. I'm going to write it down real quick so it's easy to see. X equals 100 divided by 2 is 50 minus 2y. The 2's cancel out, so it's just y. Then you'll be left with x equals 50 minus y. That's your rearranged simplified equation. And now what you can do is just directly plug this into the area formula into x. Let me do that real quick. Okay guys, so here I plugged in the x value, which is 50 minus y from here. And when you go over here, you can see that you can expand this y because it's all in the same terms. It's all in terms of y. So expand the y and you'll get negative y squared plus 50y equals a. Now the third step is taking the derivative of a. So this is just normal power rule. I taught this in my previous video. Bring down the power, multiply by the coefficient, and then minus the power by 1. So negative 2y is going to be the first term plus 50. So the derivative of a is going to be negative 2y plus 50. Okay guys, so here's the derivative of a. I wrote it right here. Now the next step is make this whole equation equal to 0. So substitute a prime as 0. It will be negative 2y plus 50 equals 0. So I'm going to write that down real quick. And then after that, you're going to solve for y. Okay. Negative 2y plus 50 equals 0. Now you're going to rearrange and find just the value of y. So move 50 to the other side and then divide it by negative 2. Let me write that down. Okay, guys, I rearranged for y. Oh, sorry, I don't know why this is erased. Okay, So here it's negative 2y equals negative 50. Move the 2 down, divide it. Y equals negative 50 divided by negative 2. And y is just 25. Okay? Now you have your... Sorry, I forgot to label which is which. So let's suppose my y is my length. Okay, I got the value for my length. Now I need to find the value for my width, which is x. So I can just plug this 25 directly into this equation and then solve for x. Okay, I'm gonna do that real quick. Okay, guys, I plugged in the 25. Here, for y, I substituted 2 times 25 is 50. And then now that you have only the variable x, you'll solve for x. So move the 50 to the other side. 100 minus 50 divided by 2 is just 25. So you get your x value, which is your width, as 25. So to rephrase it, you can say, well, the length and width must be 25 and 25 so that the area is a maximum. Okay, now we can move on to another question. Okay, guys, so here's the second example, and it said, and it says, a box with an open top is to be constructed from a square piece of cardboard 3 meters wide by cutting out a square from each of the 4 corners and bending up the sides. Find the largest volume that such a box can have. So first of all, we need to try to understand the question. It's given us a square piece of cardboard, and it's going to cut out a square from each of the 4 corners so that it can be folded up into a box. Because when you fold this side up, the the part that you cut out is going to be your height. Okay? Because when you fold it, that corner that you cut out is going to give it some elevation. Okay? So you can just directly tell that the h is going to be x as one of your variables. Okay, so the first thing I want you guys to do is write down each of its side, what each of its side is. So the length of this side, uh, one second, I need to find a way to say this better. Okay, guys, here, I wrote these down so you can find out the new measurement of the square piece of cardboard, okay? The original length, also, before I start this, I want you guys to know that the length and the width are going to be equal since this is a square and not a rectangle, okay? So the new length is going to be 3 minus 2x. And x, because you don't know what each of the squares that you're taking out is worth. So 2 of these are being taken out. That's why this is 2x. Okay, so the length is going to be 3 minus 2x. Sorry, I'm writing with my left hand. So, okay, 3 minus 2x. And then the same goes for the width. This side, also 2x is being removed, and since it's a square, the width is also going to be 3 originally. So 3 minus 2x. And the height. The height is the elevation, right? This height is the same as the square being taken out. And as we mentioned before, this square is equivalent to x because we don't know what that is. So the h is just x. Okay, now that we have the measurements for our new cardboard square, we can now start to make our first equation. Okay, guys, so to write our equation, it says find the largest volume. We're going to be using the volume formula. And this is something I think you guys already know. The volume formula is length times width times height, okay? So just straight up write volume equals length times width times height. Let me do that. Okay, I wrote volume equals length times width times height. Now look above. You have every single one of them, so just plug it directly into the formula. Okay, and then you can start expanding it. Let me write it out. Okay, guys, so here as I said before, I just substituted each for its value. Okay, 3 minus 2x for the length, 3 minus 2x for the width, and x for the height. Okay, the next step is just to expand everything. And after expanding, you get the volume as 4x cubed minus 2x squared plus 9x. Okay, now you can just continue everything like the questions that we did previously. You just take the derivative of v. When you take the derivative, just use power rule and bring down the powers and everything. Yeah, it's the same as before. I'll just write it down. Okay, guys, I wrote the derivative here. By using power rule, we just get this as the derivative. And now the last step is setting the equation equal to 0. So I set the derivative equal to 0, and I took out a common 3 from the derivative, okay? Now the next part is just factoring. I've made many videos on factoring, so I'm not going to explain it in this video, but you just factor the inside. Either you can use quadratic formula or you can factor it by hand, but I'm going to get the factors and I'm going to come back. Okay, guys, so after factoring, you have two answers, okay? Before picking your one answer, you need to be very careful because one of these is an extraneous root. You cannot use it as the answer as it doesn't fit the criteria. You're finding the largest, you're finding the largest volume, okay? We're finding the largest volume in the question. So one of these, when you plug the x in, is going to give us a volume less than the other. I'm going to put up screenshots from the calculator so you can see, but the answer, the last answer is going to be x equals half, okay? That's going to be our x value that we solved for. 1 second. Okay, guys, so because the question is asking for the max volume, you don't need to find any of the other coordinates, although they're going to be the same, you don't need to worry about that. Just directly plug in this into the formula that we made before, and you are going to get your volume, okay? The reason why I didn't pick 3 over 2 as the answer is because when you plug this into x, you're going to get a volume that's less than 2, therefore making it not the largest volume, okay? That's why half is going to be the value of our x. Okay, guys, so that's it for today's video. I'm sorry for making the video long, but it was necessary to explain the questions properly. But yeah, that's part 2, and I think that's the final application question for maximum and minimum that I'm going to do. If you have any questions, please leave them in the comments. And yeah, that's it for today. See you guys next time. Bye.